This is the next experiment that we are doing, which is the Charles law experiment, which is experiment number 3 in our syllabus, which is Charles law. To investigate the Charles law for air and find the number of moles of air in a given canister. Actually, this is our given container. Yeah, aluminum container is given, and we are going to calculate how many moles of air molecules are available inside. Theoretically it is impossible, but practically we are going to guess how many number of moles of air molecules are available inside. So to do that, this is our experimental setup. We have a cooling bath, or maybe we have a calibrated measuring cylinder. That's calibrated measuring cylinder is over this one. This is our calibrated measuring cylinder, and we have a gas canister and also a water bath. You can see an excellent water bath is available, which is used to heat the water. We have a dial which is connected with a coil, and water is filled in the water bath. How to perform this experiment? It's a bit long because of it will take some time to heat up the water, but apart from that the experiment is quite easy. First one, we must measure TB. TB means temperature of the bath. You can see here we have placed a thermometer, and that will give the temperature of the bath. Let's write it here. And L0 is the 0 millimeter. L0 is, you can see here, this is the calibrator measuring jar that will give that. This is used to measure the expansion of gas molecules. That will be measured over here, calibrator measuring jar. So what we have to do, we have to, for different temperatures, what is expansion, that has to be measured from the calibrator measuring jar. So first, initially the temperature of the dial have to be kept 30. This is our dial. Switch on the dial and put it for 30, and then wait. There are two lights are on. One is green and another one is yellow, or you can see orange. You wait until this light goes off. That means coil is getting heated. Once the coil reaches 30, this will be off. Once this light is off, we have to write the temperature of the water. This is the water. How do we know the temperature of the water? We have placed a thermometer, and this thermometer will give the temperature of the water and write it here. Sometimes it may be exactly 30, or it may be 29 or 32, whatever it may be. You're coming, you write it. And delta T. Delta T will be TW minus TB. This is TW means temperature of the water. TB is TB. Before we start the experiment, we have measured the temperature of the bath. That you have to write. And then we must measure the L. How to measure the L value? Once the temperature of the bath reaches 30, use the gas canister and keep it inside the hot water. So what is happening? Because of the hot water, the air molecules inside the gas canister getting receive the heat of the water, and it starts, the gas molecules gives a push over here, so that the piston will move up, because this is the gas molecules giving a pressure on the piston, so that the piston will move up, and that will give the L value, how much length it is giving a push, or how much it expanded, how much amount gas molecules are expanded through measurement of L value, which is L is equal to millimeter. That's for the first case. And the second case, increase the temperature from 32, put for 35, and once the temperature reaches 35, put the gas canister inside, or the gas cylinder, calibrate the gas canister inside, and measure how much it is expanded over the calibrated calibrator measuring jar, and write it here. For each temperature change, measure the TW and also L value. TW is from the thermometer, what is the temperature of the water, and L from the calibrated measuring cylinder. And all the other values are calculation. This is a calculation part. Delta L will be L minus L0 calculation, and delta V, this is a formula. Delta V is equal to pi r square into delta L. After that, what we have to do, use this formula. Of course, we have to draw a graph using the tablet data, plot a graph of delta V versus delta T, and finally calculate the slope and find the number of gas molecules in the gas canister. Don't ask whether it is exactly the same number or not. It is an approximate value. Use this formula to find the value of N. All the other values are known values that will verify the gas Charles law, which is when the volume is expanded, when the temperature is increased, the volume also get increased. That is a direct proportionality. When the temperature of the gas molecules get increased and the volume also getting increased, the volume increased, and so that it is giving a push to the piston. That's why we are able to experience expansion over here. That clearly explains this experiment, and good luck. Thank you.